Thank you, Thomas, and thank you all for coming here. So as Thomas said, I'm going to talk about two things. One, I want to talk a little bit about academic progress, research progress inspired by the financial crisis, and then I want to talk a little bit about measurement. I think the other speakers will talk more about measurement, but I just wanted to say a little bit about that as well. Okay, so maybe I can start here. If I go back to, say, 2005, 2006, the dominant way in which people thought about asset pricing is through an equation and a model along these lines. Here, P is a price, D is a dividend, some cash flows coming in the future, and M is the way an investor is valuing stochastic payoff streams, how he's thinking about how to price the risk of cash flows. The dominant models, the two most popular models, the two most dominant models of this kind in thinking about how investors price risk are the Campbell-Cochrane consumption habits model, which emphasizes how investors think about consumption risk over the business cycle. So thinking about recession risks, for example. And the long-run risk model of Bansal and Yaron, which thinks about how investors think about how long-term consumption growth might be risky and how that impacts asset prices. These are beautiful, elegant models. Everybody in graduate school is still taught these models. They are simple models, and they have a great virtue. The way I like to think about these models is they're like looking at the world through a telescope from Mars. You know, you look through the world through a telescope from Mars, the world looks very smooth. The fact that garbage is picked up on East 4th Street doesn't really matter. The world looks very smooth, and lots of kind of little things along the way drop out. So in the financial market context, what this type of model smooths over is the fact that investment requires delegation. You hire somebody to make investments for you. Markets are sometimes segmented. There are different players in different asset markets. There's financing needs. There's liquidity needs. There's a whole collection of institutional things that make up the asset market structure that this type of model kind of neglects. And for many purposes, that's okay. But as we know, models are wrong. This is a wrong model. And where is this model particularly wrong? It is a model that's been particularly wrong for thinking about the crisis. So I'm graphing here the departure from covered interest parity, the euro-dollar basis, which, as probably many of you know, essentially holds pre-crisis. Covered interest parity works extremely well until about the crisis when it blows up. It's very hard to make sense of this through the lens of thinking about consumption risks or long risk. In a way, the point is that what happens in a crisis is all of these things that are smoothed over suddenly start to reassert themselves. The granularity of the world sort of shows up as being important in how asset market prices are determined. Segmentation, repo markets, all of this stuff starts to come to the fore and plays a pretty critical role in determining asset prices. Covered interest parity is a particularly a nice one to make this point, but there's many things that one can point to. Many collection of spreads, the CDS bond basis, a whole collection of places where you see this type of phenomenon, and it's a phenomenon that shows up particularly in a crisis. So how should one think from a modeling standpoint about the transition from non-crisis to crisis? So how does the world grow from a place in which things look smooth to a world in which the granularity of the world starts to show up and starts to affect prices? So what I'm showing you here is a graph from a paper of mine with a co-author, Jiguo He, from the AER from 2013. And what this graph shows on the x-axis is a measure. This is a theoretical model. So in the x-axis is a model-based measure of the equity capitalization of the financial sector. Okay, so to the right, as you go further to the right, you're better capitalized. And then on the y-axis, I'm graphing the risk premium that comes out of this model. So the required return per unit of risk that comes out of this model. And you can see that the main feature of this model is if you are to the right, if you are in the part of the state space where equity capitalization is high, risk premium are low, and probably more interestingly, shocks to equity capitalization have very small impacts on the risk premium. In a way, the model looks like a non-granular world. Shocks are absorbed. The system is sort of self-correcting. Essentially what happens is you have shocks. There's slack in the system that takes up the shocks, and the world kind of functions as normal. I have a red line there, and if you look to the left of that red line, you see that the risk premium starts to take off. And what's happening there is the crisis effect starts to show up. So the outstanding feature of this model is the transition from a period in which markets look relatively well-functioning, granularity is not an issue, to a part of the state space where that is an issue. And moreover, the further left you go, the higher the risk premium gets. So for example, if you're on the left side of this red line and there are losses to the financial sector, they'll push you further to the left, and the risk premium goes up even further. There's this sort of spiraling fire sale effect that many people have talked about that comes out of a model like this. What I've just talked about is asset pricing, but one can also think about how these types of effects will show up for macro. So again, what I'm graphing here is I'm graphing two things from this model. I'm putting in a shock into the model, a 1% shock to productivity, and tracing out what the model implies for risk premia as well as investment, aggregate investment in this model, depending upon which state of the world you're in. Whether you're on the right side, so the kind of unconstrained, well-capitalized part of the world, or to the left side, where you're in the constrained, granular part of the world. The dashed line gives the normal period, and the solid blue line here gives the crisis period, the granular period. And you can see what happens is in the normal phase, a 1% shock just reduces investment by 1%. It's kind of what you'd expect. In the crisis period, the same shock gets you a much bigger impact on investment that slowly reverts. And why does this happen? It's basically through the risk premium channel. What's happening is if you are in the part of the state space where the world looks more granular, a shock increases risk premium, so it increases required returns, and that immediately affects lending and investment, and that creates an effect on investment and for macro. So what I've just taken you through is really a sampling of research in this area. The crisis triggered a reevaluation of standard models, and it has also led to a whole bunch of new models. And I've taken you, just given you a taste of some of the models that have come out, but there's many models of this kind, and they all have this type of feature. So the outstanding questions are: when does intermediation matter? When does it affect asset prices? How does it affect asset prices? How can we detect these effects in the data? There's a whole bunch of empirical work. I talked about covered interest parity, but there's a whole bunch more empirical work that then thinks about the data and thinks about how to match the data to models. There's a related set of issues outside asset pricing, thinking about how these same effects affect macro, how in crises do these asset pricing phenomenon show up in macro, and likewise there's a bunch of data work thinking about crises and macro outcomes. So my read on the academic work in the last decade prompted by the crisis is it's actually been very healthy. There's been a whole bunch of work, lots of modeling, and we have learned a lot, and I'm expecting we will continue to learn a lot about these issues going forward. The second thing I want to talk about is measurement. So if you, I'm putting this picture up, which I put up before, and and to remind you, what this picture shows you is how the risk premium depends upon the capitalization of the financial sector. So if you look at this picture and you're thinking about the world and trying to ask questions about, is the world a stable place? The central question you're going to be asking yourself is, where is this red line, right? So this model has this feature that there's a cliff. And if you're to the right of the cliff, everything goes on okay. If you're to the left of the cliff, things take off. So if you're looking at the world, you want to know where this cliff is. And I don't mean this from a modeling perspective. You'd like to know this in the data. Are we near the cliff, or are we farther from the cliff? So, for example, in the world today, and this is to pick up on a point that Doug also made, there's been lots of concern about, say, leverage loans. Leverage loans have grown dramatically. It's probably the case that corporate leverage is stretched in places. There's a bunch of places in which it looks like valuations are stretched and quantities are stretched in a way. And there's a good chance that when things stretch, they unstretch. The question for looking at the world and thinking whether this it means that there's a macro risk involved is a question of how close we are to the cliff, right? If we're way to the right of this point, we can hit shocks, but the system sort of absorbs the shocks and lets it go. If we're to the left, then we have a problem. So the question of systemic risk is a question of if I add a shock to the world, am I likely to end up on the left side of this red line? Am I likely over the cliff? And centrally, what you'd need to know for that is you'd need to be able to figure out where W hat is. You'd need to figure out where the cliff is. And within the context of a model that I write down, which I have written down a model, W hat is very clearly defined. Everybody in the world in the model knows exactly where W hat is. But if I back out of my model and I start thinking about the world, the central question that comes up is, what is this? What data do I need in order to figure out whether we are at the cliff? So the model has a very clear answer. The model's answer, it's the capitalization of the financial sector, loosely leverage. And so if I take the model literally, I would say go measure leverage and go ask yourself, is capitalization sufficient? Now, the model that I've written down is a very, very simple model. It has really only one variable that drives financial risk, which it's a capitalization. That's the only thing that matters. In the world, there's much more. There are issues about segmentation. There are issues about debt markets and how well debt markets are functioning in financing trade. And so if I step back and I ask the measurement question being, do we know from the data whether we are close to W hat or not? Are we close to the cliff or not? I am not sure. I really don't know. And in fact, in many ways, we probably could have asked this question in 2007 as well. What data do I have to know whether we are close to the cliff? It's very clear, looking at the crisis, going back through the crisis, we would like to know this. If we had known this in 2006, life would have been we would have had a different trajectory, I'm guessing, than we do today. And so one thing that worries me looking at models and thinking about data is that our measurement systems have not kept up. They've not responded to the need of the crisis, which is we really would like to know what W hat is. And I don't feel in any significant way that we've gotten there. So I'm going to put this slide up. This is a quote from a writer commenting on the Depression. And I put this up just because it tells you that measurement problems are problems that we've had for many, throughout history, and measurement problems are solved sometimes by better measurement. This is a quote that comes from a book that a article that Gary and Marcus Brunnermeyer and I wrote called Risk Topography. And what we argued in that chapter is that a useful thing for the world, this is a chapter that we wrote in 2011, a useful thing for the world is to try to figure out measurement systems to understand where W hat is, which led to a NBR book that invited suggestions from a whole bunch of authors, including some in this room, for how we would measure a risk in a way that we could, in the end, form something like a risk topography of the US economy so that we can use that data to figure out where W hat is. I'm listing a bunch of chapters here, and I still think this is a good idea. As I'm thinking about this question of leveraged loans, I don't know, and I certainly don't feel like we're anywhere close to where we should be on this measurement challenge. So I'm going to stop there. Thank you.